Welcome to today's session, my dear students. In the last class, we understood difference between an ore and a mineral. And the important statement was all minerals are not ores, but all ores are minerals. Because out of some minerals of a particular metal's ore, in which mineral the percentage of metal is more, that mineral becomes an ore of that metal. Okay, so it depends upon the percentage of a metal in a mineral, and if it is more compared to all other minerals of the same metal, then that is taken as the principal mineral, or the first grade mineral, or the high quality mineral, or that mineral becomes the ore. And from that ore, we take out the metal using a suitable method. So this all we studied in our last class. Now today we go with the journey into the extraction of metals. Method of extraction depends on the position of the metal in the reactivity series. That means, let us recall once again previous discussion where we understood that if the metal comes under the reactivity, if the metal comes under the more reactive category, it will never occur as a free state because it is highly reactive. It will occur in the combined state. If it is occurring in the middle of the reactive series, moderate reactive, it may occur in the native state to some extent, or it will occur as a combined state. And third category, if the metal is chemically least reactive, then that metal will never occur in the combined state, only in the free state or native state. It occurs with some minor impurities, and that is taken out cytode. That's why today's first point of discussion is what method of extraction depends on the position of the metal in the reactivity series. Extraction of metal involves getting rid of the unwanted rock to obtain concentrated form of the mineral, then obtaining pure metal from the mineral by chemical reactions. If you follow these two steps, metal is ready in our hand from the ore. Okay, so first step is what? First step is generally metals occur in the form of common state, in the form of rock or mineral or ore in the lithosphere. So where a lot of impurities are there, maybe it is a sand or a soil or a mud or a clay, some other impurities, plus some chemical impurities which are associated with the metal. Okay, if all those physical and the chemical impurities are removed, then we get a metal in the pure condition. Okay, so first point is what? Removal of the impurities. Okay, then purification of the metal so that metal is ready, and the entire process is called as what? The extraction of metals or metallurgy. This is our reactivity series. Okay, first five very reactive, never found as free elements, extracted by electrolysis. See, he has told depend upon the metal nature on the reactivity series, we select a suitable method. Now for the first five which are most reactive, very reactive, so because they're reactive, they occur always in the command state and the bond is very strong, and to break the bond, to break the attachment, we have to go for the electrolysis method. Here we break the bond using the electric current, and that is known as what? Electrolysis. We learn afterwards. Now time being, let us understand electrolysis means breaking the bond between the metal and the other attachments using the electric current. That is called electrolysis. Why we have to break with only electric current? Because electric current is most powerful. Okay, with this energy we can break the bond, which is very strong. Okay, why bond is very strong? Because the metal is more reactive. More the metal reactivity, more stronger is the bond. Less the reactivity, less stronger is the bond. Okay, right. Now if the metal is moderate reactive, okay, uh, it may found in the earth crust as oxides or carbonates or sulfides. That time we extract by the reaction with what? Either carbon or with carbon monoxide. Okay, So here oxygen is most reactive non-metal in the atmosphere. Okay, and metals are also reactive. When the metals are reactive, when the oxygen is reactive, then we expect a metal oxide formation in the earth crust. That's why most of the metals occur in the earth crust as metal oxides. So apart from occurring metals as oxides, metals also occurs as carbonate with the carbon dioxide, okay, with the sulfides, with the sulfur, and in some other different forms. Okay, and to remove these attachments for the moderate reactive, we use a suitable converting agent. It is a chemical. That converting agent is called as what? Agent which breaks the bond to separate the metal from their ore. Okay, normally we use either carbon or carbon monoxide. So these two are called as the best converting agent. Okay, right. How it is done? We take an example afterwards. Okay, plus time being, please wait. Now, if the metal is less reactive, then they never occur in the command state. They occur as a free state. Only slight some easy methods are there. So with those methods, we can separate the metal. So extraction of metal and this method depends upon the position of a particular metal on the reactivity series. This is given only method. Electrolysis, reduction using carbon or carbon monoxide are found in the native state and use a simple method. Now, this is the arrow mark or ray diagram, we can say. Okay, from the ore, how the metal is made. First, ore is made into powder. Whatever we get after blasting the hill, after taking out ore from the earth crust, they are in larger sizes. Therefore, it is first crushed. Okay, powdered. That is called what? Pulverization. So the ore which is crushed and powdered and grinded to a smaller sizes, then that ore is called as what? Pulverized ore, because this process is called as what? Pulverization. After making a powder, then we apply suitable method. Okay. Then we go to the concentration of the ore. Means what? We remove the impurities. If you have taken some 20 lorries of the ore, then 20 lorry after removal of the mud becomes only 5 lorries. Remaining all mud impurity will go. That is called partly concentrated ore. After making the ore, after concentrating the ore, then you go for the main concentration, where there are some chemicals which are closely associated with the metal. They can be removed only by chemical method. You apply physical method. By chance, by using physical method, if you are unable to separate the impurities, then you go for the chemical methods. Whether it is physical or chemical, our aim is to remove impurities so that it is concentrated. Means what? More and more impurities are removed, more and more percentage of metal is made. That is called what? Concentrated ore. From that, using the reduction method or converting agent method, we prepare a metal which is slightly impure, maybe around 95% or 90% we get, and that is made 100% pure, or at least 99.99, or at least 99% pure by some method. That is called pure metal. Okay, so excuse me. From the ore, pulverization, physical method, chemical method, so that ore is concentrated. Most of the impurities are removed. Only ore is concentrated. Percentage of ore is increased. Then, using a suitable method, it is reduced. It is converted. So, almost pure metal we get with some impurities, that is also removed. So that ultimately, finally, we get a pure metal which is ready to use for day-to-day work. In this way, we follow all these methods, and all these methods stepwise follow. For this, we require concentration, okay, time factor, money factor. Okay, so all these, keeping all these in the mind, we go for the method, and the entire process is called as what? Metallurgy, or extraction of metals. Okay, so please practice this ray diagram, and in the tomorrow's class, we go for how metal is what purified, how the metal is extracted from the ore, with examples. Okay, so that this extraction of metals becomes easy. So till then, have a nice time, keep waiting, and thank you and all.